To solve this differential equation, we do the same thing. We're going to separate the variables and integrate. So the first step is I'm going to go dy by 1 over y is equal to dx over x. Okay, so integrating this side here, I'm going to end up with log 1 minus y, and I have to times that by or divide that by -1 because of the chain rule. And then I'm going to end up with log x plus c. Okay, so solving this, I'm going to put that negative into here, so I'm going to end up with log 1 over 1 minus y. That's going to be a reciprocal power. And here I'm going to write this as log x plus log c. And I'll call that C2, and that represents, this constant is going to be represented by log C2. Combining this, or I'm going to simplify this, combining this side, I'm going to end up with log of C2x. Okay, and then I could solve for the c here. I'm just going to drop the logs, so I end up with 1 over 1 minus y equals C2x, and rearranging this for y, it becomes 1 over C2x is equal to 1 minus y. Okay, and then solving for y, I end up with this expression. Okay, so at this point I've been given also a coordinate on the graph, so 1, 1, 0, so initial position. So I'm going to plug that into my x and y. So I take that value, I'm going to plug it into x and y. Y is 0, x is 1, and I'm going to solve for my C2. So this is equal to 1 minus 1 over 1 times C2, and solving for that C2 value, it looks like C2 is equal to 1. So when I solve this, it's got to be 1 minus 1 on this side, so C2 is equal to 1. Okay, so my final equation then is going to look like this. Y equals 1 minus 1 over x. So there is the solution to the differential equation. Okay, and so I separated, I integrated, I used the position here to solve for C2 or for the C value, and I have my equation. So here it's been asked to draw the slope field for the general differential equation. So to do that, I'm going to use this function here, this one right here. That's going to generate my slope parts. So I'm going to do it, start here, so -1, +1. So x is +1, y is, sorry, x is -1, y is +1. So if y is +1, we're just going to have horizontal tangents here. It looks like that might be an asymptote. In fact, it looks like it is. So we have here then x equals -2, y equals 0, so we get -1/2, so we get kind of a low slope here. We get x equals -1, y equals 0, so we can have a little bit steeper slope here. X equals 0, this is undefined, so undefined along here. Actually, this is going to be undefined, so we should have a whole vertical asymptote along here. X equals 1, y equals 0 is the one that we were solving for, so that's the slope of 1, +1. Okay, and then we end up with x is 2, y is 0, so it's going to look like this. X is -1, y is -1. We end up with a slope of 2 over 1, so -2 over 1, so it's a little bit steeper like this. And if x equals 1, y equals -1, we end up with the same but positive. So there's our graph. The solution that we solved for, that we were looking for, was this solution here going through this point. And so it looks like it's going to go something like this, which it does. We know that this is a reciprocal function.